In this chapter, we are going to focus on alkanes and naming alkanes. These are different than alkenes or alkynes or aromatic arenes because they are only single bonded sigma bonds that are sp3 hybridized. The structure of alkanes is going to be, because these are all sp3 hybridized, there are going to be 109.5 degree bond angles between each of these carbons. One of the things that we're going to start with thinking about, here's a vocab word for you, is constitutional isomers. So we think about the constitutional makeup of the molecule is going to be the same for these isomers, but they're going to be arranged differently. So for example, we have butane on the left with 4 carbons, and we have a compound that also has 4 carbons in it, 1, 2, 3, 4, but they're arranged in a different pattern and a different way. So they're branched in a chain-like manner, or there is a branch chain-like manner where there's a branching off of the longest chain. And these are going to be important. Each constitutional isomer is going to be named differently. For example, this is named butane on the left, and on the right it's 2-methylpropane. So we're going to talk about naming these. Different constitutional isomers will have different names according to terminology that we're going to talk about in just a moment. Here are some different examples, right? This is a 4-carbon group. Here's a 5-carbon group that has different constitutional isomers. These are all made up of 5 carbons, but they're arranged differently. You can see 1 branch here. We have 2 branches here off of the longest chain. We can draw these carbons out using these skeletal structures, and we want to just look for the longest possible chain that's straight and without any branching. So we have 1, 2, 3, 4, 5. So these are all 5 carbons long. These are not constitutional isomers. They're called conformational isomers. So that is just kind of spinning the structure around amongst the carbon-carbon bond, but they're still the same length, and it's just how they're bending in space. They're not necessarily moving physical covalent bonds from one carbon to another, for example. What we're going to look for here is how to name these, or otherwise known as nomenclature. We're looking for the longest chain to begin with, and these are what I would like you to remember. For a single carbon, it's methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, and decyl. I added the YL ending because that is when it's a substituent group off the longest chain, which we'll talk about. But if it is one single long chain, you end it with an ANE ending. That means it's all single bonds. If there's a double bond in there, it's ENE, like methene, and if it's triple bond, it's a methyne. So this is the base of that word, the meth part, eth, prop, but, pent, hex, hept, oct, non, and dec. 1 through 10, those are what I'd like you to remember. And again, it's just the chain length that we're talking about. So this is the first step in naming using the International Union of Pure and Applied Chemistry, IUPAC naming system. When we meet for class, we'll talk about this first problem, looking at 5 different constitutional isomers. And remember, we can change the longest chain length. So you're going to just only use 6 carbons, but draw different lengths of carbons and different branched chains off of those carbons to be able to draw the 5 different isomers that are available for that type of compound. Alkanes can come as straight chains, but they can also come as cyclic compounds. So these are cyclo, we add in the front to name them cyclic, and cyclopropane, which is methyl ethyl propyl, so that's 3, methyl ethyl propyl butyl, so that's cyclobutane, methyl ethyl propyl butyl pentyl, cyclopentane, methyl ethyl propyl butyl pentyl hexyl, cyclohexane. These are all different types of cyclic compounds we may see, And so these are some of, especially the cyclohexane and cyclopentane, we see more of those structures found in biological compounds, because the bond angles for the cyclohexane is actually 109.5, just as it is in a straight chain carbon group. We get smaller and smaller bond angles, and that's going to change some of the chemistry that might be happening with these compounds. But these are all found in biological systems to some extent or another, the cyclohexane being the most prevalent. One of the reasons for this systematic naming is because then we can actually distinguish the difference between constitutional isomers. So it's not as useful to just say C20O2H85, right? So it's because we don't know how they're arranged and organized, and the structure is really important to the function. So we're going to have to name these, and here's an example of a name for the IUPAC name for the generic compound ibuprofen. So trade names would be Advil, for example, or Motrin. The systematic name, what's in here, there are numbers, and there are some of the groups that you may have recognized from the previous slide, where we have methyl, propyl, another propanoic acid. So these are different things that are telling us different things about the compound. The propanoic acid, that's talking about this carboxylic acid, is on the longest chain here. That is 1, 2, 3. That we're going to count here. These are considered substituent groups. That's a phenyl group. And the numbers just tell us where these things are coming off of the certain chains that we're talking about. All right, so let's get into how to start naming these things. There are 3 different parts typically to a name of these IUPAC naming systems. First, there's the prefix, which is going to be where are the substituents. And when I say substituents, that means something that's kind of coming off of the main chain. So that's the prefix, is usually telling us what and where things are happening. The parent chain is the longest chain, so it's the backbone on which these other things are attached. And the suffix is going to tell us which type of functional group we're working with. So that's why in the last chapter, I made you take a quiz about functional groups, because in order to name those, you need to know the functional groups and what they look like. So in this chapter, we're mostly focusing on alkanes, which just means everything's single bonded. And so that is they're all going to have an ANE ending. Right back here on this slide, we had propanoic acid. Oic acid is a carboxylic acid functional group. So depending on the type of compound you hear, they're going to tell you something about the functional group. You've heard of ethanol, and so that's a 2-carbon chain with an alcohol on the end of it. So instead of ethane, it's ethanol. Let's look at a few more examples of these. So using the IUPAC naming system, the first thing that we have to do is find the longest chain. So here is an example of the correct way to find the longest chain. We're going to count 1, 2, 3, 4, 5, 6, 7, 8. So that's octane, because there are no double bonds in here. So that's the first step. You can try different combinations or different pathways, kind of like a maze to some extent, right? I can count from 1, 2, 3, 4, 5, 6, 7. That's not correct. We have to count this way. That gives us the longest chain. So whatever way that it's drawn so that you can count the longest continuous chain, that is the correct backbone structure. One thing that might happen as you're counting your chain is that there might be more substituent groups coming off. So again, there are 2 substituent groups, meaning groups that are being added on to that long chain. Here we have 2 substituent groups, and in this way, if we count 7 atoms long, we just have 1 substituent group. So we want to count it in a way that we have the most number of substituent groups off of our chain. In this case, we have a methyl substituent group, In this case, we have a methyl ethyl, so we'll have an ethyl substituent group. Here is a 3-carbon group, 1, 2, 3, methyl ethyl propyl. This is a propyl group, and it's actually an isopropyl group because it's off of the middle carbon instead of off of the end carbon. And we'll talk about some of those names in just a moment. Here are a couple of different examples of naming these. So we have octane, we have the longest group. Both are 8. But which way do we count them from? From the left to right or right to left? Well, it really depends on where you'd hit your first substituent group. So you want to number the longest chain, but then give the first substituent group the lowest number. So if we count from left to right on this compound, we're going to have the 2 is the first methyl substituent group. If we count from right to left, we have a 1, 2, and 3. That's the first substituent group. So this is incorrect because this gives us the lowest possible number. Here's an example of a 6-membered ring, so a hexane. And we're going to look at what is the difference counting this compound from the left to right or right to left. Here we have the second substituent group. The first substituent group is on number 2 carbon, and then a number 3, and then a number 5, versus a 2, a 4, and a 5. Because the next group is a 3 compared to a 4, this is the correct way to name this because it is the lower number. So we're going to always try to get the lowest number on our substituent groups. When we number these, so here's another different way to look at this. So we have a hexane, we have 7 long chain. We're going to count from left to right or right to left. We count a 1, 2, and a 3, an ethyl group, 4, and a 5. We have a methyl group. So we want this, if they're equivalent, right? So we have a 1, 2, and 3 methyl, 4, 5 ethyl. We want to give the lowest number to the alphabetically first compound. So ethyl is alphabetically before methyl, even though it's longer than the shorter one, right? Where it's about the alphabetical nature of the name versus how long that chain is. Here we have an example of an octane, right? The 8 is the longest chain, so that's going to be octane. And we have 3 substituent groups. We have a 2-methyl. We have a 5-ethyl. And we have a 6-methyl. Because we have the ethyl group is alphabetically first, I am going to put that first. Remember, the prefix is going to tell us what and where. So we have a 5-ethyl, and we have a 2 and a 6 dimethyl. So we have di, tri, tetra. So these are other naming systems that we'll learn as well in a second. So we have di, tri, and tetra for 3 or 4 groups, and so forth in that manner. So we have on the 5th carbon, we have an ethyl group. 2 and 6 carbons, we have methyl groups, and dimethyl octane. So this is the proper name for this compound right here. One thing to notice about the name here is that between numbers and letters, there are always dashes. In between numbers, there are always commas. And in between different group words, there's nothing. Notice that dimethyl octane. We only put dashes or commas. And if it's 2 different words, we just kind of glue them together. I'm going to walk through some naming examples and how I would name these. Here in this example, we have a methyl ethyl propyl butyl pentyl. So I kind of just have memorized this to the point where I can just count them as their names. It's kind of like learning a different language, right? So it's just counting in a different type of language. Methyl ethyl propyl butyl pentyl. So that's the pentane at the back end. I'm going to count from the back end because I can see that that's going to give me the lowest possible numbers. So we have a 2 and a 3, and there are two of them. There are two methyl groups. So 2,3-dimethyl pentane. On this next compound, we have a methyl ethyl propyl butyl pentyl hexyl heptyl octyl octane. So that's our base of that compound. If I count from left to right, I have 1, 2, 3, 4, and 5 versus 1, 2, 3, 4, and 5. Now we're going to give the ethyl group the 4, so that's the methyl ethyl, right? Substituent group. This is alphabetically first, so I'm going to give that the 4 and the methyl group the 5. So 4-ethyl-5-methyl octane. Now we'll go down to this compound, which has 3 different substituent groups. So we have a methyl, ethyl, propyl, butyl, pentyl, hexyl, ectyl, octyl. Sorry, octyl, octane. And we have a methyl group, an ethyl group, and another methyl group. Ethyl comes alphabetically first, right? But we're going to count from the back end, 1, 2, 3, and 4. That's all we need to number, because then we can put those together. So we're going to have that 4 ethyl and a 3 and a 4 dimethyl, because there are two of them, octane. So this compound on the bottom right is a little more tricky. We could count from this carbon 1, 2, 3, 4, 5, 6, 7. That is one option. Or we could count 1, 2, 3, 4, 5, 6, 7. So sometimes there might be different options. But remember, we can get the most number of substituent groups if we count through this way. So we have a 1, 2, 3, 4 different substituent groups. If I counted this chain, I'd have 1, 2, only 3 substituent groups. So remember, we want to try to get the longest chain, and then if there are 2 chains that are same length, we want to do the most number of substituent groups. If I go from right to left, I would number this 1, 2, 3, 4, 5, 6, 7. And that will give me a group on the 2, the 3, the 4, and the 5, versus if I do 1, 2, and a 3, right, from the left to right, the first number would be a 3 versus a 2, so I know I need to count from right to left. Here I have a methyl, another methyl, and 3 methyls, so that's trimethyl on the 2, 3, and 5 carbons. 2, 3, 5 trimethyl. And on the 4th carbon is my methyl ethyl propyl, so propyl heptane. There are some special substituent groups that you should be aware of. Now, normally when we have a substituent group, we hope that it's just a long straight chain, and that's easier, right? So if there's a parent, then we have the substituent group off of a chain. So we have methyl ethyl propyl. This is a normal propyl substituent group, and it's on that last carbon. If we have an option though where we could have this bonded to the middle carbon, and this is still a methyl ethyl propyl length chain, but it's in the middle of the carbon, on the middle carbon versus the end carbon. This we call isopropyl. So this will get its own type of name if we have a short substituent group that is bonded to that middle carbon. Propane has that special substituent, so does butane. So here is an example of butane, so methyl ethyl propyl butyl, so there's 4 carbon groups. If it's on the end, it's just a normal butyl group, 1, 2, 3, 4. If it's on, for example, the 2nd carbon, it's going to be a sec-butyl because it's a secondary carbon, sec-butyl. And if we are at the end and it's kind of after it's kind of like that, it has the isopropyl group, but there's another carbon here, This is called the isobutyl. And finally, there's a tert butyl, which sounds pretty funny, but that's because it's a tertiary carbon it's attached to. And so we have methyl ethyl propyl butyl, and it's that middle carbon that's attached to 3 other carbons, so it's called a tert butyl. So these, as well as the isopropyl, these you will probably see in certain named compounds pretty frequently in organic chemistry, in your book, on practice exams, potentially on quizzes or exams in this class. So here I'd like to walk you through another example for giving the IUPAC name for this compound. And this is kind of the steps below, but we're going to have to find, the first thing you always want to do is find the longest chain. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. We could try 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So I found the longest chain in this way right here. So we have to decide if we're going to count from left to right or right to left. And here it looks to me I'm going to have to count from right to left because on the 1, 2, 3 carbon, I already get a chain versus 1, 2, 3, 4. So we're going to go from left to right. So let me number these as 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know nonane is our backbone structure. On that 3 carbon, right, we have a methyl group. And on the 5 carbon, we're going to have that weird tert butyl, right? Tertiary carbon, 1, 2, 3. It's actually quaternary, but it's bonded to that. We're kind of assuming that that's not a part of that. So that's why we get the 5 tert butyl. Oops. And this is where we have to look at the naming alphabetically. And technically, even though it's a T here, we're going to start with the butyl part is actually what gets priority, not the tert part, because it's a butyl. So we'll do the 5 tert butyl, 3 methyl nonane. And you can see that is what we have down here. That's how you would name that compound. Not only are you going to have to name things from the structure, but you'll also have to derive a structure from the name. So the first step is this is where the skeletal structure really comes in handy. So if we're looking at this compound right here, 6-isopropyl 3,3,7 trimethyl decane. First step is to look for that backbone, decane, and draw that decane. So we're going to draw a line starting on the bottom corner, methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl. That's the 10. So that's the base, that's the parent chain. And then we're going to, since these are numbered, we can just find the groups that we're going to attach. So the 6 will have an isopropyl, a group with 3 carbons. And then on the 3, 2 on the 3, 1 on the 7, we have methyl groups. So 2 on the 3, 1 on the 7, and this would be the finalized structure here. In class, we will practice naming structures and creating structures from names, and so that these hopefully slides will help you walk through that process as well. In addition to straight chain naming, I'm going to talk briefly about naming cycloalkanes as well. And the way that we do this is to first find the parent cycloalkane. So this is 1, 2, 3, 4, 5, 6. That's a hexane, and we add that cyclo in front of it to mention that it's in a cyclic form. So cyclohexane. So that's the first part, is finding that parent chain. And the next is to number the substituents. So if we have a single substituent, there's no need to number the location. So this, for example, is methyl cyclohexane. There's just one spot on here. Tert-butyl cyclopentane. There's just one spot that it can be. If we have it here, 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 it's all equivalent. But for this example, we're going to number these. So we have a methyl group and an ethyl group. We're going to number this with the low number on the alphabetically first, and we'll go 1, 2, and 3. We try to get those numbers to be as low as possible. So we have 1 ethyl, 3 methyl cyclohexane. Here are some of the further rules for ring structures, and here is where we're going to have, here's again the cyclohexane, and we count from 1, 2, 3. So we're going to have this be 3 versus counting 1, 2, 3, 4, 5. We're going to have the lowest possible number on our substituent groups. If we have different substituent groups, like that other example, 1, 2, 3, we're going to have the lowest number, and we're going to start the 1 at the alphabetically first compound, right? Versus counting from the methyl, we're going to count from the ethyl because it's alphabetically first. Just like our other naming system for the straight chain, the longer chain gains priority. So if the longer chain is the cyclohexane, then that gains the priority. But if the longer chain is the straight chain and we have a cyclic compound that's only 4 carbons long, then we'd name that as a substituent group off of the long straight chain. So that is just something that you might see in some of the homework, for example. Here's some other ring just examples. So we have a methyl and ethyl group. So the 2 carbon ring is going to be, or 2 carbon straight chain is going to be a substituent off of the 4 carbon cyclobutane group. So here, just one group off of there, so we don't need to number it. Ethyl cyclobutane. Here's an example of 1, 2, and 3. We're going to do sec-butyl because it's 1, 2. This is a secondary carbon on the methyl ethyl propyl butane. Remember that kind of prefix part of that butyl group, the B comes alphabetically first, so we're going to start with 1, 2, and 3 for that 3-methyl, and it's a cyclohexane again. Here we have a cyclohexane and cyclopentane. We'll do another cyclohexane. Pretty simple, 1, 2 dimethyl cyclohexane. So we have the dimethyl, just like we were doing with the straight chain carbons. And finally, we have 1, 2, 3, 4, and instead of 1, 2, 3, 4, 5, right? This gives us the lowest number, and they're all ethyl groups. 1, 2, 1, 2, 1, 2. So we have a 1, a 2, and a 4 triethyl. It's a cyclopentane. So we gave the numbers the lowest groupings, and we have that tri prefix on the ethyl because there's three of those. In some alkanes or cycloalkanes, common names are used. So here's an interesting structure: cubane, housane, churchane, bascadane, dodecahexadrane, fullerene. You may have heard of buckyball. So these are all different types of common names that are sometimes used for these different compounds. Feel free to try to give this IUPAC name. We'll go over this in class as well. And pause here and then also give these names, and then you can also create the structure from these names as well. This is all I wanted to do for today, and on the next time we meet, we'll go over the naming worksheet. We'll also talk about some of the physical properties of these compounds as well.